Let's clear the air. When the astronomical community pivots, when time allocation committees start bumping scheduled observations from multi-billion-dollar assets, it's not because of a strange light in the sky. It's because the orbital mechanics are impossible. This object isn't just approaching our sun. It's falling into the gravity well on a trajectory that screams, "Not from around here." Its hyperbolic excess velocity, the v-1050, is off the charts. For the past month, we haven't just been looking at it. We've been running its orbital solution through every computer we have, from the Minor Planet Center to JPL's Horizon system. The data is unambiguous. It is not bound to our star. And yes, time is running out. Not in a cataclysmic way, but in an operational one. We have a rapidly closing window for observation before it reaches perihelion, its closest approach to the sun. That's when it's most active, and it's also just before it vanishes into the solar glare, a point we call solar conjunction, where the sun's noise blinds us. Soon the object will be unobservable from Earth, lost in the noise of the star it's visiting. This is a standard operational challenge for all deep space missions. You plan for these conjunctions, but in this case, it's an inbound object, and it's our only chance. This leaves us with a flood of data to solve a central mystery. What is this thing? Officially, its designation from the Minor Planet Center is 3I Atlas. The 3I is the critical part. It means it's the third confirmed interstellar object ever detected. The I is a designation the MPC does not hand out lightly. It requires a confirmed hyperbolic trajectory with an eccentricity significantly greater than 1. A value so high it cannot be explained by any gravitational assist from Jupiter or any other planet. It means it came from far away, from the orbit of one of those other stars in the galactic disk. We have absolutely no way of knowing which one. Tracing its orbit backward through a dynamic galaxy, with stellar motions perturbing its path for millions or billions of years, is a computational impossibility. We're not even sure which galactic population it belongs to. Is it from the thin disk, the populated star-forming region our sun lives in? Or is it from the thick disk, a much older, more diffuse population of stars? That's where the ancient speculation comes from. If it's a thick disk object, it could be a primordial planetesimal, a building block from a solar system that formed perhaps 10 billion years ago, when the universe's chemical makeup was different. This is only the third time we've been able to confirm one of these visitors. The first, of course, was 1I Oumuamua. That 2017 event changed everything. It wasn't a cigar-shaped rock, not really. That shape was just the leading model derived from its extreme light curve, the way its brightness tumbled. What really baffled engineers and physicists about Oumuamua was its motion. It displayed non-gravitational acceleration. It was speeding up as it left the solar system, as if a low-thrust engine were firing. But we saw no coma, no outgassing, no propellant. That is a propulsion expert's nightmare. We still don't have a consensus on Oumuamua. The non-gravitational acceleration looked like a textbook solar sail, but the physics of its tumble didn't match. The outgassing theory requires a propellant we couldn't detect, like pure hydrogen ice. It remains a profound mystery. 3I Atlas, however, is already looking weirder, but in a completely different way. Then there was 2I Borisov, discovered in 2019. Borisov has become the overlooked middle child because it was, in a word, reassuring. It was boring, and boring in this context was revolutionary. Borisov looked like a comet. It had a coma like a comet, and its chemical spectrum, rich in water and cyanide, looked exactly like one of our own Oort cloud comets. It acted just as our models predicted. Borisov was the validation we needed. It proved that other star systems also have Oort clouds, and that our models of planetesimal formation aren't entirely wrong. It was the crucial control group for this interstellar experiment. But Borisov was familiar. 3I Atlas is not. This object has quickly become the single greatest opportunity in the history of astronomy to study a genuinely anomalous, pristine, extrasolar body. And this is the classic scientific situation. The preliminary data is so bizarre that it's challenging our fundamental assumptions. The more data we get from the world's best instruments, the Liskamoyan, it makes sense. It's not just one anomaly, it's a stack of anomalies. It's forcing us to question our models of chemistry, physics, and planetary formation. This is one of those rare moments where the rulebook is being thrown out, and we are witnessing the discovery of a new class of object in real time. This is why you see observatories dropping their scheduled programs to get even a few minutes of time on this target. Officially, the object was flagged on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a robotic survey in Hawaii designed to scan the sky for movers, specifically near-Earth objects. That's why it carries the ATLAS name. When it was first flagged, its orbit was already calculated to be well inside Jupiter, between the orbits of Jupiter and Mars, but its hyperbolic nature was immediately apparent. However, once that initial orbital solution was published, a pre-covery search began. This is standard procedure. Astronomers all over the world check their archive data to see if they accidentally imaged the object before its discovery. And they found it. It was seen for the first time on May 7, 2025, in data from the Transiting Exoplanet Survey satellite, TESS. TESS is a space telescope, but it's not a survey telescope like ATLAS. TESS stares at patches of the sky looking for the minute dips in starlight caused by transiting exoplanets. This object was a photobomber, a streak of light that TESS wasn't looking for, so it wasn't noticed at the time. But finding that TESS data point was the first huge breakthrough. When that first image of 3i Atlas was taken, the object wasn't near Mars. It was still traveling in the cold, dark expanse between the orbits of Saturn and Jupiter. This is critical. That single light early data point allowed us to dramatically refine the orbital solution. It gave us a much longer baseline, which is the key to calculating its incoming hyperbolic excess velocity, with high precision. That test data also gives us a sense of its incredible speed. It's easy to throw out a comparison like saying NASA's Voyager probes took 18 to 23 months to reach Jupiter. But that's a flawed comparison. Voyager 1 and 2 were launched on minimum energy HOMON transfers to save propellant. They were coasting. A better comparison is New Horizons, which was launched on a high-energy direct trajectory. It passed the Moon's orbit in 9 hours and reached Jupiter in just 13 months. We know 3i Atlas was near Jupiter's orbit in May. It's now passing the orbit of Mars in September. It will reach its perihelion, its closest approach to the Sun, on October 29th. Then it will be flung back out, crossing Jupiter's orbit again by next spring, this time on its way out for good. That velocity profile is how we know for an absolute fact that this is an interstellar object. It is traveling far, far too fast to be gravitationally bound to our Sun. Its trajectory is a perfect open-ended hyperbola. It has an eccentricity, significantly greater than 1. For context, Earth's orbit is $16, nearly a circle. Halley's Comet is $9.7, a long ellipse. An object with $1 has exactly escape velocity. 3i Atlas's eccentricity is much higher. It's not just escaping, it's arriving with so much kinetic energy from its interstellar journey that the Sun's gravity can only bend its path, not capture it. It is a drive-by. Now, here is the first major anomaly revealed by that TESS recovery data. Even when 3i Atlas was out beyond the orbit of Jupiter, at more than 5 astronomical units from the Sun, it was already looking very bright. And then, over the 3-week period that TESS observed it, it got significantly brighter. This is deeply weird. It's weird compared to the 99.9% of comets we know, which originate in our own solar system's Oort cloud or Kuiper belt. Those comets are inert, dark, frozen bodies for almost their entire orbit. They are, as we say, asleep. Typically, our comets are what we call dirty snowballs, a model Fred Whipple developed in the 1950s. They are big chunks of frozen water ice, mixed up with silicate rock, dust, and other frozen gases. As that chunk of ice gets closer to the sun, it finally gets warm enough for the ice to sublimate. In the vacuum of space, it doesn't melt from solid to liquid. It goes directly from solid ice to gaseous vapor. This is sublimation. This sudden, violent release of gas is what creates the coma, the big, bright, fuzzy halo around the comet's nucleus. This is what makes a comet look like a comet. And this is the crucial point. For our comets, which are dominated by water ice, the snow line where this process kicks in is inside the orbit of Jupiter. It's roughly around the asteroid belt, at about 2.7 to 3 AU. Our comets don't turn on and develop their comas until they pass Jupiter and start approaching Mars. They are inert, dark, and inactive at 5 AU. It's just too cold for water ice to sublimate, but when Tess first saw 3I Atlas on May 7th, the object was still way out on the other side of Jupiter, in the deep cold. And yet, it was already super bright. It already had a massive active coma. This indicates that its sublimation had already begun, long before it reached the water ice snowline. This was the first smoking gun. This observation, in and of itself, tells us that if 3I Atlas is a comet, it's not made of the same stuff as our comets. Its activity cannot be driven by water ice. It must be driven by hypervolatiles, ices like carbon monoxide, CO, nitrogen, N2, or carbon dioxide, CO2, which have much lower sublimation temperatures and will turn to gas at extreme cold, far from the sun. This makes 3I Atlas wildly different from our other two interstellar visitors. It's the opposite of Oumuamua, which was infamous for showing no visible signs of sublimation at all, even at its perihelion. It was an inert rock that somehow still accelerated, and it's different from 2I Borisov because Borisov did all the usual things. Borisov turned on at the right place, inside Jupiter's orbit, and its spectrum showed it was a water ice comet. Borisov was strange only because of its normalness. This creates a fascinating triangle. Oumuamua, too cold, Borisov, just right, and 3I Atlas, way, way too hot. This trio proves that the diversity of small bodies in our galaxy is far greater than we ever imagined. But as we continue to observe the approach of 3I Atlas over July and August, it just kept getting weirder. The coma, the cloud of gas, began to form a tail, which is normal for a comet. But the one around 3I Atlas started growing, in the wrong direction. It was observed to have a tail pointed towards the sun. Now, to understand why this is so baffling, you have to understand comet tail physics. A comet typically has, two tails. First is the Eon tail. This is made of gas that's been ionized by the sun's ultraviolet light. Because it's a plasma, charged particles, it gets grabbed by the solar wind's magnetic field and pushed directly away from the sun, like a perfect windsock. Second is the dust tail. This is made of heavier dust and pebbles. It's not affected by the solar wind. It's pushed by the much weaker force of solar radiation pressure, the physical push of photons. Because the dust is heavier and still obeys orbital mechanics, it gets left behind in the comet's orbit, forming a long, curved tail. Both point away from the sun. The sun is the primary source of light, heat, and energy. But in orbital dynamics, you have to think of it as two forces: a fan, the solar wind, and a pressure washer, radiation pressure. Both forces push outward. The dog sticking its head out the window analogy is partially correct, but it's really two different forces acting on two different materials. The solar wind pushes the ions. The sunlight pushes the dust. In no standard model does anything get pushed toward the sun. So now try to imagine that dog sticks its head out the car window and its face stretches forward into the wind. That wouldn't make any sense, right? And that's why people were baffled when it started to look like the tail of 3I Atlas was forming in the direction of the sun, against the solar wind and against radiation pressure. This is the second major anomaly. Now, experienced astronomers will immediately suggest an anti-tail. This is a known, though rare, optical illusion. It's not really a tail pointing at the sun. It's the heaviest debris, gravel, pebbles, that's been ejected by the comet. Debris so heavy that neither the solar wind nor radiation pressure can move it. It gets left behind in the comet's own orbital plane. When Earth, in its own orbit, crosses the orbital plane of that comet, we see that trail of debris edge on, and from our geometric perspective, it looks like a spike pointing toward the sun. But this explanation also implies 3I Atlas is ejecting an enormous amount of large, heavy debris, which is itself unusual. These are just some of the many questions that astronomers were trying to answer when they made the decision to point the world's most powerful space-based observatories directly at 3I Atlas. This means triggering Target of Opportunity, TOO protocols, which is a big deal. It means overriding an existing peer-reviewed observation schedule. We're talking the Hubble Space Telescope, which gives us unparalleled high-resolution optical and UV imaging. We're talking the James Webb Space Telescope, the L2-based infrared powerhouse, which is the key to chemical analysis. The video mentions SphereX, which is an interesting case. It's a future all-sky infrared spectrometer scheduled for launch in this 2025 timeline, so it's plausible it's been commissioned and brought online for this. And TESS was also brought back in to take a second look. This is the all-hands-on-deck moment. It was NASA's most advanced observatory, the James Webb Space Telescope, that was able to provide the best insight so far into what 3I Atlas actually is. And as expected, we got some answers, but also a cascade of new questions. The biggest finding, the one that confirmed the test data, was that the coma surrounding 3I Atlas is made almost entirely of carbon dioxide. CO2. This object is not a dirty snowball made of water ice. It is a dirty dry ice ball. It is a massive, pristine chunk of carbon dioxide, exactly the kind of hypervolatile we suspected. The JWST's infrared spectrometers, NIR-SPEC and MIRI, didn't just detect it, they quantified it. The comet does contain some water, but the ratio of carbon dioxide to water, H2O, was measured at a staggering 8.1. To put that in perspective, a normal comet in our solar system might have a 1 to 5% CO2 to water ratio. This object has 16 times more CO2 than what you would expect to see in an average comet. This finding is the definitive explanation for anomaly number 1. It is active beyond Jupiter because its entire bulk composition is made of a material that sublimates at 78 equikakashi, not 0 degrees C, and the cloud of CO2 it's generating is now thought to be gigantic. Based on the amount of light it's reflecting, the coma has a radius of up to 300,000 kilometers. That is a tenuous atmosphere, almost half the size of the Sun, all being generated by a much smaller nucleus. This massive output has also forced observers to rethink the size of the solid object at the center. It's incredibly difficult to measure a nucleus. You're trying to find a tiny, dark object inside a blazing, diffuse cloud of its own making. It's like finding a speck of dust in a searchlight. At first, based on the initial brightness, we thought the core might be up to 20 kilometers wide. Then that was revised down to maybe 11 kilometers. But now, based on these new observations from Hubble and Webb, which can better separate the central point source from the coma's glare, it's thought that the actual size could be as big as 46 kilometers across. That's a big object. It's not a record breaker. Comet Hale-Bopp was 60 kilometers, and the giant Comet Bernardinelli-Bernstein, discovered in 2021, may have a nucleus over 100 kilometer wide. But 46 kilometers is a very substantial body, far larger than Halley's Comet. But the size is secondary. The massive amount of CO2 compared to the almost total lack of water is something we have never, ever seen before. It's basically the opposite chemical inventory of what we would expect to find in the halo of a comet. It's a direct physical sample telling us that this object was created in a star system that has very different raw materials from our own, Or at least it formed in a very different region of its protoplanetary disk. A region so cold that CO2 ice was the dominant building block, not water ice. The fundamental chemical ratios are all wrong. This is what makes 3I Atlas so genuinely alien in nature. It's not just a visitor, it's a messenger from a completely different chemical environment. But was it made by aliens? This brings us to the third and most bizarre discovery. This observation was made this summer by the Very Large Telescope in Chile. Yeah, that's the actual name. It's 4 8.2-meter telescopes that can work together. Anyway, the VLT's UVES spectrometer was able to detect the clear, unambiguous spectral signature of the Azteca nickel metal in the coma of 3I Atlas. But, and this is the part that makes no sense, it was not able to detect any trace of ATIS, iron metal. Confused? You should be. Good. Iron and nickel are cosmic partners. They are iron peak elements, the most abundant heavy metals in the known universe, sitting at the bottom of the binding energy curve. That's because they are forged together in the hearts of dying massive stars. When those stars explode as supernovae, they blast this iron and nickel out into the interstellar medium together. They condense into dust grains together. Our entire solar system, its asteroids, its moons, its planetary cores, is built from this pre-mixed dust. They are always found together in a very specific, well-understood cosmic ratio. The only time we ever see nickel on its own, completely separated from iron, is when we, as in humans, purposely separate the two metals in an industrial refining process, like the Mond process, which uses carbon monoxide to produce pure nickel. This is an artificial technological signature. So how did elemental nickel find its way into a comet's coma without bringing along any of its cosmic partner, iron? Good question. We don't know. It is profoundly weird. It is perhaps the single most anomalous chemical signature ever detected in an astronomical object. So, of course, that brings us around to everyone's favorite explanation: aliens. There is no shortage of theories out there about what kind of artificial spacecraft we might be looking at. This is the Oumuamua playbook all over again, but this time the anomalies are chemical, not physical. And in fairness to those theorists, it's not like they're just making stuff up out of thin air. All that they do is take the known data, the test brightness, the CO2 dominance, the sunward tail, the nickel no iron, and they create a slightly more speculative interpretation. For example, we know that 3I Atlas got brighter as it passed by Jupiter. Yes, it was getting closer to the sun, but that doesn't account for anywhere near the amount of brightness that was added. So this could be explained by the early sublimation of the object's unusually high CO2 content. That's the scientific model. Or, as the alternate theory goes, it could be an alien space probe that started switching on its internal systems or lights as it approached a target of interest. We've also seen the theory put out there that the object is surrounded by a cloud of CO2 because it's a giant, kilometers-long generation ship full of living organisms. The CO2 is their metabolic waste product. They are breathing out CO2 just like we do, and they are venting the waste produced into space. This is, of course, quantitatively absurd. The mass loss rate required to create a 300,000-kilometer coma is tons per second. You would need a biological population equivalent to trillions of Earths to generate that much CO2 waste. It's a non-starter from an engineering perspective. I've even heard it said that 3I Atlas might be a giant, living organism itself, a space creature out of a sci-fi novel, and it's consuming interstellar dust and gas as it moves through the solar system and releasing CO2 as an organic byproduct. And the cool thing is that as of right now, no one can say with 100% certainty that this is not true. It's just that the burden of proof for an extraordinary claim is extraordinary. It's probably not. This is Russell's teapot. I can't disprove it, therefore it's valid. That's not how science works. The null hypothesis, the default position, is that this is a natural, if baffling, object. But the same logic applies to the nickel metal. no one can say for sure what's going on with that finding. The natural explanation is itself highly exotic. It's a theory that the nickel and iron are bound in different organometallic compounds. The nickel might be a nickel tetracarbonyl, NiCO4, which is extremely volatile. The iron might be an iron pentacarbonyl, E5CO5, which is less volatile. The theory is that the comet was just warm enough to sublimate the nickel compound, but too cold to sublimate the iron one. It's a testable hypothesis. As 3I Atlas gets closer to the sun and warmer, we should cross the sublimation point for the iron compound. If suddenly iron appears in the VLT spectrum, the natural model is proven correct. If it never appears, well, you can't definitively say it's not an artificially constructed alien spacecraft. Again, it's probably not. But this is precisely why scientists and astronomers are in a flat-out panic, quickly trying to learn as much about 3I Atlas as they can in the small window of time that we have available. We have an opportunity to get a photograph of this object from a completely new vantage point as it passes close by the planet Mars in early October. It's coming within about 28 million kilometers, which is still pretty far, but in interplanetary terms, it's right next door. And it's close enough for 2 European Mars orbiters to get a decent look. The European Space Agency, ESA, will use both the Mars Express and the ExoMars Trace Gas Orbiter to observe 3I Atlas. This is a major operational change-up. Mars Express is a 20-year-old legacy mission. TGO is a modern, high-powered science orbiter. The plan is to slew both spacecraft, which are designed to look down at Mars, and point them up at this fast-moving target. They will observe it using their high-resolution cameras, like TGO's CASs and their color imaging systems. The real prize would be if TGO can use its atmospheric spectrometers, NOMAD and ACS, to get an independent chemical fingerprint of that coma. Now, it's not like we'll get a beautiful Hollywood-style close-up or anything. At 28 million kilometers, even TGO's best telescope will only resolve the nucleus into a few pixels. But that's just it. There should be just enough resolution to distinguish the bright, fuzzy cloud of gas surrounding the object from the single hard light point of whatever is at the center of that cloud. So we could maybe get an idea about the shape of the object. Is it 1 dot or 2? Is it a contact binary? And by using color filters, we can separate the color of the nucleus from the color of the coma, telling us about its surface properties. It's a critical data point. And then by late October, from our point of view on Earth, 3I Atlas will pass behind the sun. This is solar conjunction. It's a communications and observation blackout. We won't be able to see it again until December, at which point it'll be on the way out of the solar system again, having survived its fiery perihelion pass. Or not. Some comets, like Ison, disintegrate. We'll be waiting anxiously to see if it reappears, but we'll get one last chance. On March 16, 2026, 3I Atlas, now on its outbound leg, will fly past the planet Jupiter at a distance of 53 million kilometers. Still pretty far away, but we do have one active and very capable probe out there in orbit of Jupiter. It's called Juno. It's an older spacecraft, a hardened nuclear reactor-powered beast that's been in a brutal polar orbit of Jupiter since 2016. Its primary mission is to study Jupiter's magnetic field and atmosphere. Juno's original mission was actually scheduled to end in September 2025. This 2026 flyby is after its planned end of life. NASA was planning to just crash the probe into Jupiter to dispose of it. This isn't just to see what happens. It's a critical planetary protection requirement. Juno is not sterilized. We cannot risk it one day, decades from now, crashing into the ocean moon Europa and contaminating it with Earth-based microbes. So the disposal is a controlled, deliberate burnup in Jupiter's atmosphere. But another potential end-of-life mission is now on the table. The word intercept is wrong. Juno Hubakiasya cannot intercept 3I Atlas. It's in a deep polar orbit of Jupiter. It doesn't have the delta Vadas tollers, the fuel, to break out of Jupiter's gravity and chase the comet. That's an orbital impossibility. But what it can do is act as an advanced observation post. As 3I Atlas flies past the Jupiter system, Juno can use its instruments like JunoCam for optical imaging and its GYRAM spectrometer for infrared chemical analysis to observe it from a distance of 53 million kilometers. That's a lot closer than Earth will be. So, as weird as it's been studying this object so far, we are not done with it yet. There's still a lot to learn. We will get answers. We'll probably also get just as many new questions. And that truly is what makes this all so fun.